And greetings and welcome. We're taking a look at permutations with repetitions, and the page we were doing this off of was kind of like 849 or so. Technically, these problems are from the next one. But here's question 29. How many ways can I arrange 14 keys on a key ring? And they were asking whether or not the problem was circular or linear, and determine the number of arrangements. So, if I've got a key ring, let's see, and I've got like little keys on it. Here's my awesome little classic key right there. I guess one of the tricky things we'll have to consider is, would we consider this a clasp type problem where I could break it linear? And I think it'd be hard to determine because the ring itself can rotate throughout the keys so easily that it's not a clasp situation. So I would say that this is circular. And now my question is, would we consider this flippable, kind of like the bracelet with beads on it? And my guess is that it's not flippable, because if I did, the teeth on the keys would be facing in the different direction, right? Like it would be, you know, if I flip it over, the teeth don't have flippable symmetry on them. So I'm guessing not flippable would be my interpretation. Pardon me. So 14 keys, circular. That's going to be 14 minus 1 factorial, I believe, or 14 factorial over 14. So that's just 13 factorial. Let's see what I get. So 13 factorial. And that is not what the book had. This is equal to 622702008 hundo. And the book had half of that answer. So the book,
I got it right, and I have the same.
The book has 3113510 So the book's answer would have been this over 2, meaning the book interpreted this as being flippable. But I would argue that the keys are not going, like the teeth on your keys aren't going to be facing the same way. Here, let's see. Here, for sample, right? So here's my keys on my key ring. If I have it this way, all the teeth are pointing up. I flip it over, those teeth are pointing down, right? So I would argue that that's not a flippable situation, right? I wonder if someone could look at this image from the internet and now duplicate this non-duplicable key just by like tracing it and then like mass producing it. That would be bad. Is that like I just like typed in my email password like well on live stream?
I highly doubt they're gonna like search Wilmington to find your house and then.
Well, that. Oh yeah, maybe I won't say any more details about what that key unlocks. Never mind then. So, but yeah, so I would claim this is the answer based off of my interpretation.
But I got that too, and when I checked it was right.
Your version of the book had this answer?
I think so.
Is your book at your house? I know sometimes they have different versions. Okay. All right. So I know sometimes the book updates their answers. So I'm arguing this is right because of the teeth. All right. And as long as you can make a clear justification as to why you believe that, I think that I would accept your argument on a quiz if there was for some reason vague response on it. Let's see. Problem 31, same directions. 32 horses on the outside edge of a carousel. Okay, so carousel situation. I've got little horses like right here's their feet and there's the head, little ear, and the tail and their back feet, right? And they go around the carousel one direction. There's not a fixed point, so I would argue that this is circular. I don't think this is a flippable situation. Flippable. So 32 minus 1 factorial, or 31 factorial, that's going to be a huge number. Let's see, math And I get 8.222228 times 10 to the 33rd power.
What did you do on -1?
Minus 1?
Yeah, -1.
Because for circular permutations, if I have n objects and it's circular, circular, there we are, it would be n minus 1 factorial, or it's also the same as n factorial over n. You have two versions of the formula. They both are equivalent to one another if you simplify them. So that's why I was doing the 32 minus 1. So there's a couple homework questions for you. Hope that was good stuff. Have a great day, internet friends.